You're listening to the Agentic Engineer Podcast, weekly AI agent intelligence for builders. I'm your host, and with me as always is my co-host. Let's get into it.
Issue 13. Supply chain attacks hit OpenAI directly. TanStack NPM packages compromised. Code signing certs exfiltrated for macOS, iOS, and Windows. AWS drops a CLI Agent Orchestrator that runs Claude Code, Codex, Hero, and Gemini in parallel. And a paper on evolving agent memory through population broadcast. Let's go.
Quick rundown. The mini-Shy-Hewlett attack compromised TanStack NPM packages, hit two OpenAI employee devices, and stole code signing certificates. Full cert rotation by June 12th.
AWS CLI Agent Orchestrator coordinates multiple coding agents in parallel TMUX sessions via MCP. Supervisor Worker Pattern. Tool of the Week.
And Forge evolves agent memory via population broadcast. 1.7 to 7.7x improvement over zero shot. No weight updates required. Just prompt evolution through natural selection.
Last week's poll. You want agents that get better over time, not just agents that run. This paper delivers exactly that.
The big one. TanStack NPM supply chain attack hits OpenAI. Code signing certificates compromised.
Okay, this is the third supply chain attack we've covered. Light LLM in Issue 7. Client ejection in Issue 3. Now TanStack. At what point do we admit the dependency graph is the primary attack surface for agent-powered software?
We're past that point. Here's what happened. The attacker published malicious versions of real TanStack packages on NPM. Not typo squatting. The actual packages, compromised at the maintainer level.
So this isn't some random package with a similar name. This is TanStack. Millions of downloads. Used everywhere.
Exactly. The payload targeted developer machines specifically. It exfiltrated signing credentials rather than user data. Two OpenAI employee devices were hit. The attacker got code signing certificates for macOS, iOS, and Windows applications.
Wait. Code signing certs. That's not just embarrassing. That's a skeleton key. A stolen code signing certificate lets you ship malware that every operating system trusts. macOS Gatekeeper trusts it. Windows Smart Screen trusts it.
Your users' machines trust it. The cert is the distribution trust layer. If you have it, you can push anything and it looks legitimate.
So what's the agent angle here? Because this newsletter isn't a general security newsletter.
The agent angle is terrifying. Coding agents install packages constantly. They run npm install as part of their normal workflow. An agent that installs a compromised package propagates the attack without any human reviewing the dependency.
And agents do this 24/7. No review. No gut check. No developer going, this package updated at 3 a.m. on a Sunday, that's weird.
Right. The attack surface isn't just developers who install packages. It's agents that install packages on behalf of developers around the clock without review. Every npm install an agent runs is a trust decision made at machine speed.
I want to push back slightly. OpenAI's response was actually good here. Detection within hours. Immediate disclosure. Full cert rotation timeline published. No attempt to minimize.
Agreed. The response is a template for how to handle supply chain incidents transparently. But the response doesn't fix the structural problem.
Which is what? What should teams actually do today?
Pin exact dependency versions. Enable npm's ignore scripts by default and allow list scripts explicitly. Set minimum release age in your lock file config, 72 hours minimum. Verify package provenance via npm's SigStore integration.
And for agents specifically?
Sandbox them during installs. Network isolation during dependency resolution. No credential access during npm install. If your coding agent installs packages autonomously, it should do so in a container with no access to signing keys, tokens, or credentials.
The uncomfortable truth is that the more autonomous your agents become, the more they amplify supply chain risk. We need agent-specific dependency governance, not just lock files. Policy engines that prevent agents from installing packages that haven't been vetted.
And nobody has built that yet. There's a startup idea in there somewhere. Quick hits. 5 stories. Rapid fire.
Semvel. Semantic code search for agents. 98% fewer tokens than grep. indexes a repo in 250 milliseconds, answers queries in 1.5 milliseconds, all on CPU. Returns only relevant snippets instead of full files.
This is the kind of infrastructure that makes agents actually efficient. Your agent stops reading 50 files to find one function. Works with Claude Code, Codex, Cursor, OpenCode via MCP. 328 points on Hacker News.
The token savings are real. 98% reduction versus grep and read workflows. That's not incremental. That's a different cost structure entirely.
Agent memory. Persistent memory for every coding agent. 11,870 stars, plus 7,103 in 1 week. That's explosive growth.
Universal memory server via MCP. 95.2% recall at 5 on long MEM eval. Cuts token usage from 19.5 million per year down to 170,000. That's roughly $10 a year instead of hundreds.
BM25 plus Vector plus Graph Search Fusion. 1 NPM install, and your agent remembers everything across sessions. This connects directly to the Forge paper we'll cover later. Memory is the unlock.
OpenAI Codex goes mobile. For million weekly users. Full thread management, approvals, and real-time diffs from your phone.
The agent in your pocket pattern is becoming real. Review a PR from the subway. Approve a deploy from the coffee shop. Remote SSH is GA for enterprise. Programmatic access tokens and hooks are GA.
I'm genuinely curious how many people will actually approve production deploys from their phone. Feels like a feature that sounds cool until you fat finger an approval on the bus.
Fair, but the read-only monitoring use case is solid. Watching your agent work while you're away from your desk.
React Doctor. Your agent writes bad React. This catches it. 10,051 stars, plus 2,430 in a week.
One command scanner that scores React codebases 0 to 100 with actionable diagnostics. Installs as an agent skill. Ships as a GitHub action for PR regression gating.
The agent linter category is emerging fast. Your agent writes the code, React Doctor tells it what's wrong, the agent fixes it. Closed loop. This is the quality feedback loop people voted for last week.
Bedrock Advanced Prompt Optimization. Write once, run on any model. Optimizes prompts for any model while comparing original versus optimized across up to 5 models simultaneously.
For teams running multi-model agent architectures, this eliminates the rewrite every prompt per model tax. Write for Claude, auto-adapt for Nova, Llama, Mistral. Prompt migration between models.
This is AWS saying model lock-in is over. Pick the best model per task and let the tooling handle the translation. Paper breakdown. Forge. Self-evolving agent memory via population broadcast.
This one is fascinating. The core insight, you can evolve better agent memory without touching model weights. No fine-tuning. No RLHF. Just prompt evolution through natural selection.
Here's how it works. You run a population of React agents. Each one has its own natural language memory. Rules, examples, heuristics. After each episode, the top performer's memory gets broadcast to the entire population.
So it's literally survival of the fittest, but for system prompts.
Exactly. Agents mutate their received memory slightly. Next generation runs. The key mechanism is broadcast, not graduation. Sharing the best memory matters more than filtering out the worst agents.
What kind of improvements are we talking about?
1.7 to 7.7x improvement over zero-shot baselines. 29 to 72% improvement over reflection, which was the previous state-of-the-art for prompt-based learning. Major failures reduced to approximately 1%.
7.7x over zero-shot? That's not marginal. That's a different capability tier.
And weaker models benefit disproportionately. Tested across GPT, 4o, Claude, Gemini, and Llama. The models that start weakest gain the most from evolved memory.
So you could run a cheaper model with evolved memory and potentially match a more expensive model with a generic prompt?
That's the implication. The paper doesn't make that claim directly, but the numbers suggest it.
Okay, but who's actually going to run a population of agents to evolve their prompts? That sounds expensive.
You don't need the full framework. Start simple. Run your agent 10 times on the same task. Keep the system prompt from the best run. Feed it to the next batch. You don't need Forge to benefit from the core idea. Let agents compete. Keep the winner's memory.
That's actually practical. A poor man's Forge. Run 10, keep the best, iterate.
And if you're running agents on repetitive tasks like code review, data processing, monitoring, this approach could find better system prompts than you'd write manually. The agents discover the rules through trial and error.
Time saved, 7-minute read versus 45-minute paper. 6.4x compression. Tool of the week. AWS CLI Agent Orchestrator. Run multiple coding agents on one project in parallel.
Here's the problem. You have Claude Code for architecture decisions, Codex for bulk refactoring, Hero for spec-driven features, QDeveloper for AWS-specific work. Running them one at a time wastes hours.
And running them simultaneously on the same codebase without coordination is a recipe for merge conflicts and broken builds.
The CLI Agent Orchestrator solves this. Supervisor worker pattern. One supervisor agent decomposes work and assigns tasks. Worker agents run in isolated TMUX sessions. 3 MCP primitives handle coordination. Handoff for synchronous delegation. Assign for async fire and forget. And send message for inbox-style communication between workers.
So the supervisor says, front-end goes to Claude Code, back-end goes to Codex, infrastructure goes to QDeveloper, tests go to Gemini CLI. And they all run in parallel.
Each agent runs in its native environment. No adapter layer. No lowest common denominator abstraction. Cross-provider mixing is the whole point.
What happens when two agents try to edit the same file?
The supervisor pauses workers that hit conflicts. You can attach to any worker's TMUX session to observe or intervene. There's a web UI showing real-time progress across all workers.
Human in the loop when needed, autonomous when not. That's the right pattern.
Setup is pip install CLI Agent Orchestrator, then chow init in your project. Configure your agents in a YAML file. Run chow run with your task description. Watch them work.
When would you actually use this? Give me the concrete scenario.
Monorepo refactors. Feature work that spans front-end, back-end, and infra. Migration projects where you want QDeveloper handling AWS resources while Claude Code handles application logic. Any project where different agents excel at different parts.
590 stars so far. Early days. But the concept is right. The future isn't one coding agent. It's a team of specialized agents coordinated by a supervisor. This is the first real tool that makes that practical.
And it's from AWS Labs, so it's not going to disappear in 2 weeks. Agent Index Update. Weekly Star Tracker, May 20th.
OpenClaw at 372,834. Plus 2,109. Down slightly from last week's 2,650, but still the undisputed leader at nearly 2x the next framework.
The big story this week is N8N, plus 1,075. First time breaking 1,000 since we started tracking. Workflow automation is eating into pure agent territory.
LangGraph at plus 579 and CrewAI at plus 495. Still battling in the orchestration tier. LangGraph pulling slightly ahead this week.
Semantic Kernel at plus 46 and Strands Agents at plus 45. Both flat. Microsoft's investment clearly flows to Agent Framework at plus 189 for the third straight week.
LangChain at plus 614. Solid. Diffie at plus 840. Still strong after last week's breakout performance.
The market keeps expanding. Everyone's growing. But the growth rates tell you where the energy is. N8N crossing 1,000 is the signal this week.
Hot take. Context engineering beats chain of thought. The paper proves it.
A new paper tested 5 model families across 3,475 episodes. The finding, programmatic state abstraction improves agent return 76% per token.
76% per token. That's massive. But here's the kicker.
Adding deliberation tools, chain of thought, self-reflection, planning, to hierarchical agents degrades performance 3.4x while costing 2x more tokens.
Wait, making your agent think harder made it worse and more expensive?
That's what the data says. 3,475 episodes across 5 model families. This isn't a cherry-picked result.
So the just add reasoning orthodoxy is wrong.
For hierarchical agents, yes. Clean task decomposition and structured context beats deeper per agent deliberation every time. The agents that win aren't the ones that reason longest. They're the ones that see the right information at the right time.
This connects to the tool of the week. The CLI Agent Orchestrator is context engineering. It gives each agent exactly the context it needs for its specific task. No bloated reasoning chains. Just the right information at the right time.
Stop adding thinking steps. Start engineering better context. That's the takeaway.
And it explains why agent memory got 7,000 stars in a week. People are figuring out that what you feed the model matters more than how long you let it think.
The reasoning maximalists won't like this paper, but the data is clear. That's a wrap for issue 13 of the Agentic Engineer Podcast. Subscribe to the newsletter at theagentecengineer.waltsoft.net and follow us on YouTube at the Agentic Engineer Pod. Share it with a friend who's building with agents. We'll be back next week. Until then, keep building.